Bismillahirrahmanirrahim. Assalamualaikum. A very good day to you all. In this video, it is the last video on the topic screw. We are talking about 8.12.1, the shear joints with eccentric loading. Okay, so this content is taken from the Shigley Mechanical Engineering Design book, and all the images is taken from the book itself and also from Google Images. Okay, so what is an eccentric loading? Eccentric loading, by definition from Google, shows that eccentric loading is a load which is applied outside the centroid of the element, column, beam, foundation, where it is applied. The bigger the distance of the centroid, the bigger the eccentricity. Okay, so it said that in the previous example, the load distributed equally to the bolts in the load acted along a line of symmetry of the fasteners. The relative of a shear joint undergoing eccentric loading requires locating the center of relative motion between two members. Okay, we have learned before about the bolts, about everything. All are talking about bolts that are located balanced. Okay, balance. But how about when it is not eccentric? Well, how about it is not balanced? So this is the cardboard. This is the cylindrical cardboard. Where is the balance? Balance is I put the load at the middle of the cardboard. Like I put like here, it become balance. Okay. So eccentric loading meaning that it is not so balanced, slightly left, slightly right, but the the structure can function. The structure can function. It's just that for some reason you cannot put it at the center of gravity. Okay, like this, uh, cardboard. When I rotate it, of course the center gravity must be at the middle. But for some reason you cannot put the bolt or something else or anything. Any subject is related. Not only the bolt, not only the screw, the shaft, the spring. What you have learned from the textbook, also talking about the same thing, meaning that you cannot put it at a center position. Okay, you fight slightly, slightly to the left, slightly to the right, slightly to the up, down, everything. This is called the eccentric load. Okay, the thing about eccentric load, we have to find it in order to calculate the eccentric load. We have to find its centroid first. Okay, we have to find its centroid, represented by this uh, X and Y position, and then you can see, okay, because the centroid will be balanced. Some structure, okay, some structure, it is similar, left and right, left, right, okay, left, right, has the same symmetry, so no problem. We know immediately the centroid is at the middle. Some structure is like that, okay, like not rectangular, okay, but it have but has slightly different. So you have to find the center of gravity. Maybe it's located here, maybe it's located here. Okay, so this is the center of gravity. Okay, in many instances, the centroid is located at symmetry. Like just like I draw before, most of your structure will be located at symmetry. You can safely tell that is at the middle one. Okay, centroid is at the middle one. Okay, even when you see the schematic drawing of that design, okay, you can see here, okay, you have learned about schematic drawing and everything, schematic representation. You already know where the location of centroid from the drawing itself. Okay, from drawing itself, usually at the centroid, at the middle one, usually, but not necessary. The thing is, you have to find the centroid. Okay, so this is what I mean. You see the picture here. Okay, this is among the schematic diagram. Okay, see here the word RC, the word R. Okay, C is the centroid, uh, FCRC. Okay, we will encounter this word again. Okay, just take note for the word R. Okay, for convenience, the center of the bolt on the left and the right beam are drawn to a larger scale, 8 to 7C. The point O represent the center of the group. Is assumed the example of all bolts are the same diameter. Note that the force shown are the resultant force. Okay, uh, R represent the resultant force. R here is the resultant force. Okay. Okay, moment load. This is what we want to find. Okay, moment load or secondary shear is additional load to the bolt due to the moment Mi if R B are irradial distance. Okay. From the centroid, the moment load are rated as follow. So M1 actually is not resultant load. Resultant load is the resultant load. Okay. R here is the radial distance. Radial distance. What does it mean by radial distance? Okay. If it is conveniently shown that, let's say this is the bolt have diameter. Okay. uh, okay, supposed to be centroid here, at the middle one. Okay, and then cannot be at the middle one for some reason here. Okay, it's not at the middle. Okay, so this is the radial distance, radial 1, this is the radial 2, this is the radial 3, this is the radial 4, and so on, because its its position to the centroid is not the same. Radial 1, 2, 3, 4, 5, everything is not the same. So how can we find the moment load? Remember, moment equals to force times radial. Okay, force is given by the weight of the load. Let's say the weight of the bolt, not bolt now. Is the attachment lah. When the bolt is already in this assembly, like you see in the example in the previous video, here figure 824. Let's say this is figure in the previous video. You see, you can open the previous video, you see the example they given, example 86, this figure. Okay, let's say this figure is not centroid. Okay, the force is the weight of all that figure. Okay, so centroid here 1, 2, 3, 4. Okay, so you have, it is a different distance, different because it should be at the middle, but since it's not at the middle, it have many distances. Okay, so the F is the moment load, and the force taken by each bolt depend on its radial distance on the centroid. So the bolt farther centroid take the greatest load, and nearest bolt takes the smallest. Of course you can know. Okay, let's, for the moment, diagram, you can see when you extend your hand. Okay, when you have a long your hand, you put the load on your hand. Okay, you feel heavy, at your shoulder. If the load near to your shoulder, not that heavy, you're not that heavy, for a long time you feel heavy, of course. But if you extend your hand like that, you put the load, you will feel heavy at your shoulder, because long long distance. Now short distance, not so heavy, you feel not so heavy. This is what you try to understand. I give you example to make you try to understand what is the meaning by the shortest distance, what is the meaning by the longest distance. Okay, greatest load and lowest smallest load, and this is the resultant load. And then when you get the resultant load, then you can calculate the loading, the force for all the bolt and everything. It is important to find the resultant load. Okay, so that's all for the video. For the finish already, we talk about screw. I wish you the best. I wish you to learn more. If you don't find it difficult to understand, repeat the video. If you still don't understand, uh, read the book. Okay, and maybe you can find from other sources. Try to understand the screw, because screw you will see every day. Every day you see in the screw, you see screw. Uh, you sit on the chair, have screw. Your table have screw. Everything have screw. So it's an ever going process. Uh, People want to eliminate screw, but in ongoing process they are doing a lot of research on screw. So that's all. Thank you very much. Okay, goodbye.